cooperate. Okay. And help me out. That equation was
C. 2m plus 15.
15? Okay. And then it asks, so that's the cost of the car, cost of renting a car, where M is the miles she drives in a day. Yeah. So then part A says, so what does M represent?
The slope or the rise of the wind.
I love, it's an unfortunate choice, I understand. But this is cost of renting a car, and then you can drive a certain number of miles per day. So what is it, how much does it cost per mile?
32 cents.
Yeah, and see how that's a ratio? That's a slope. 32 cents per mile, rise over run. Okay, maybe. And then what's this mean? What if she, so the first question actually tells you, what if she drove no miles? She goes to rent the car, and then she's like, sits in the car. Huh? Yeah, there's the cost of just getting the frickin' car, right? And then they add on it so much per mile. I like it. It might. So if any of you guys ever worked for commission, a friend of mine worked at Circuit City like a million years ago. You walk into that place. Oh, does Circuit City still live?
Is that there?
You walk in there and people attack you because they live on commission. Like, I got this guy. He's my guy. I'm like, I'm just going to go somewhere else. So part A says, what if you drove nowhere? And that's just going to be, of course, 15. So the cost will be $15 even if you don't go anywhere. I like it. So it's like if you call the second hotline and it costs $5 to connect and then $1 for every additional minute. You got to pay $5 even if you immediately hang up. It's going to show up on your. Too bad for you. All right. Let's part B. Did you have a specific part you had a question about? Whoever asked this?
C and D.
C and D. So you're sitting there like, this is nice. Yeah. Part B is just another plug in. Yeah. I gave part C away a bit. Part C is interpret, what is the slope? Let me not use the letter M because M means miles, but what's the slope?
32 over 1.
Yeah, 32 watts per what?
Cents per mile.
Well, be careful. Yeah, 32 cents, but $0.32 per mile, right? So then you can interpret, and if you wanted to, you could make it 32 cents per mile. By the way, did I already talk about this? There's a bowling alley down at the bottom of that steep road next to Fletcher. Yeah. I went there a long time ago, but they used to have this. Do you understand how that's less than a penny per hour? Do you see that? Do you see that? That is not even a full penny per hour, which is not what they meant. And I never got enough assholishness in me to go in there and say, got you one, here's a penny, keep the change. Looked at Lane for an hour. What they meant this, of course. Or they meant this. You guys understand that? Do you guys see that? No? 0.99 cents is not a penny.
No, it's 99.
Right? 0.99 cents is not even a full penny. $0.99 is 99 cents. So they kind of combined the two, and then they opened the door for an asshole math person. I am an asshole, but I was just missing like this much more assholishness to go in there and say something. I got it. And they're like, well, the shoes cost $50 an hour. Like, you. Anyway, and then that's, so basically to interpret a slope, you almost just have to figure out what the units are. And that's your interpretation. So it's amount of money per mile. And then and then what about the y-intercept? We figured it out already. What's the y-intercept? In this case, it's not really a y, is it? It's a what intercept? What letter is acting at the y? C. So what's my C intercept? Good try. Try again.
0.
Ah, there we go. 0. I really, I don't just do that again. Like I said earlier, I'm an asshole, but that's not an indication of my assholishness. It's to save you from yourself. If you're used to seeing both parts for the y-intercept, you're not going to make silly mistakes later, or you make less silly mistakes. What does that mean? You basically figured out part A. That is just the what?
Cost.
Just the cost to get into the car, right? Is that our, so that's the physical interpretation of what those numbers in the equation mean. And then part D is to graph it. Now graphing this looks pretty gross, right? So part D, if I look at this slope, that is pretty gross. One thing you could do if you wanted to, well, there's a couple things you can do. The y-intercept is 15. And then it goes up 32 cents per mile, right?
Yeah.
So one thing you could do is, well, how can you write 32? You can write it 0.32. What does that look as a ratio? 0.32 is what fraction? 32 over 100. So you could do something like this. It's actually 32 for every 100. Is that, so you could do, here's 15, right, 30, 45. So then you can do this one, 100, 200. Do you kind of start to see where I'm going with this? So if I have decimals, you can always write the decimal as a fraction, and then you can try to base your scale. So what does this mean? I go up 32 for every 100. So if I start at 15, I would go up 32. Where's 32 take me? What's 15 plus 32? 47. And I would run 100. So the point would be around right there. Yeah, Jeff, good job. And I can go up another 32, and then over another 100, right? So then there's my line. I can't stop myself. I didn't mean to do the whole problem, but I did. Yes?
Can you put on the line 96, 97, 98, like this, instead of 100, and that's it?
So, can you see why I made my scale this? Why did I choose to make my scale 100?
Because of the 30.
Because my slope, the way I've written it, is by hundreds, right?
So, there's still 100, 96, 97, 98, still 100. Short space. 96, 97, 100.
Oh, no. No. Because, all right. All right, let me see if I can do this correctly. Ready? So let's leave this alone. If you saw this, what would be the issue? Can anybody see what the issue would be here? For example, is there an issue there? What's the issue? That's 10, that's 10, what's the big deal? There is an issue. Stick with your guns. What's the problem? Right here, I've designated that a tick mark is 90. And then all of a sudden I'm saying it's 10. No. So you can't start at 95, 96, 97 because that doesn't make sense. What's this tick mark mean? 95. And then you're saying, no, now it means 1. Your scale must be consistent, and that is automatically going to be 0. So your scale changed and went from 95 to 1. Okay, good, good, good. You got to be really careful. It's got to be consistent scale. Now,
I have a question over there.
yes.
32 over 100, but you went up over 32. You picked 42. Why?
15 plus 32 is, if I go up 32, what's
Oh,
15 plus
okay.
32? Yeah, because I'm starting at 15. I'm not starting at 0.
Yeah.
Why am I starting
I
at
got
15?
it.
Because that's the y-intercept,
Right, right.
or in this case, the c-intercept. So this would be cost, and this would be miles.
So you always add where
So
you
if my
see your scale
slope,
first plus
if my
zero.
slope is a decimal, right? I can just rewrite it as a ratio, because I know slope really wants to be a ratio, and a decimal is a ratio. You just have to be comfortable with all the, this requires me to go 100 in the x direction, so let me make my scale something I can handle that with. Maybe. So that problem had a decent amount of niftiness to it. You guys didn't like that one. Okay. Oh, anything else from homework? No, okay. Standard for like 15 minutes. Standard. All right, that's just gonna freak me out. Oh. Yes. Oh yeah, you had another one.
Just for this issue.
Oh, okay, this is a great example we were just talking about. So this is 318, 0.1x plus 15. Okay, this is beautiful. Can you guys try to do this, if you haven't done this yet, based on what we just talked about? Try to graph that. Because that's what it's asking for, right? The graph?
Yes.
Okay, beautiful. Graph that.
Using this slope and wire.
Of course, yeah, of course. Because are we at the point where if I ask you what's the slope, can you tell me?
Yes.
Yes, you have to be. What is the slope?
M equals to
0.1.
Oh, I'm sorry.
And then you can write that based on what we just talked about, which I'm not going to say until I do it. You can do what we just did to make it rise over run, right? You know what the y-intercept is? So go ahead and graph it. Shame is just hang out, because obviously you're already trying to. Just wait. I want to make sure everybody gets a chance to try before I give it away. Give it away. Now. Yeah, you got it. What's that point though? Oh, is that 16?
Yes.
Yeah, okay.
It's hard to get this short.
But you could have made, now here's the problem.
Not my mistake.
This is saying it's 10, and then it's saying it's 1. So again, your scale is inconsistent. So you can make the scale by 5, so it would have been easier to work with. So what's the immediate way I can rewrite this? 1 tenth, right? That's 1/10.
How did you do that?
All right. This represents 4 whats? Hundreds. This represents 5 tens, 50, right? This represents 6 ones. So hundreds, tens, ones. See how I keep dividing by 10. So what place must this be? Tenths. So this represents 7 tenths. This represents 8 hundredths. 9 thousandths. Now watch, I'm going to really blow your mind. Isn't 7 tenths 700 thousandths?
So if I did 10 over 100, that would be, right?
Yeah, it would be, but it's just like they're both 10 times bigger than they have to be. So we call that? Isn't 8 hundreds is 80 thousandths? All right, what's 700? Now they all have the same denominator, right? So what is that? Which is what that whole thing is. So if I do it bit by bit and then recombine them, I get what the whole frickin' thing is. I mean, of course I do. I have to. Just like if I do 4 hundreds plus 5 tens plus 6 ones, I get 456. The problem is we don't work with this side much. You work this to death when you first start learning numbers and shit, and then you go, oh yeah, moving line. I mean, it's like we don't do enough of this, so that we get more used to that side of things. It's almost silly for me to go, if you add 400 plus 510, you get 450, where's it's amazing. But we don't, that side you're kind of like, I didn't know you could do that. Some of you guys are, right? But that, of course, works the same way as that side because it's all the same number system. Of course, it works exactly the same. Oh, sorry, all right. The main thing there is just what the places are. So that's 1/10. And now it's not that big of a deal, right? With slope, fractions don't scare us at all. They shouldn't, because each side means something. It isn't even 1/10. It isn't a fraction. It's go up 1 over 10, right? So it's not nearly as scary as just a fraction in the wild. So what's the y-intercept?
0.
Look at that.
0. Yeah.
Sweet. Didn't even have to tase anybody to learn. And the slope, of course, we just said is 1 over 10. So now I got to be careful about scale and such. Yeah, the thing is a little bit of trade-off here.
You got the 1.
One thing you could do, now watch. What can you guys see? If I do make this by 5s, what could possibly be a little freaky? What's the slope tell me I've got to do? If I go up,
1.
and that's going to be a little hard. You see that? This is something, I'm not trying to make this problem harder. I'm trying to show you the flexibility you have and why you want to use it. So one thing you could do is you could instead make this by 1s, which, do you understand that kind of sucks?
Yeah.
And I'm hoping you guys are going to get more used to what I'm about to do. I'd rather take steps of 5, right?
Mm-hmm.
So let me just multiply this by 5. So it's 5 steps up for every 50. So what kind of scale do I want here now? By 10, it's made, right? How are we doing? So again, your scale has to be consistent. There really is nothing wrong with doing a scale of 1 here. It just kind of going up to freaking 15 sucks a little bit. Correct?
Yeah.
You could try to represent going up 1 over 10, but that's, and again, there's nothing wrong with that either. I could just go ahead and make this, I could just leave that as 1/10, make this 10, 20, and then I start at 15, right? Go up 1 over 10. Okay, there's really nothing wrong with that. But just to kind of show you where the flexibility is, I could have instead made it 10, 50, 20. And then, what was it, Jeff? 50, 100. And then went 15, up 5, over 50. It's just cleaner then. It works with the scale better. Do you have to? No. Can you? Yes. I really want that understood. I don't have to do the minimal steps. If I take 1 step up for every 10 over, that's the same as 5 steps up for every 50 over. They are exactly the same. They end up with the same line, just one zoomed out more. So here, let's do this problem. Yeah. Let's do a slightly less gross problem, and I want to
How
make a...
did you know to go up by 5? Because
I didn't know. This problem made me want to make a scale of 5, just by itself, right? 15?
yeah,
It's better than going 1, 2, 3 up to
No,
15.
yeah.
So 5, 10, 15 made sense. Which means steps of 5 would be easier to handle.
right.
So if I could just make that steps of 5, which makes that steps of 50, I could do it that way. Or I could do 1 up and 10 over, which is not as easy to see, but it's still, and then look at that shit. I mean, that's where people were having trouble. It's almost flat, it looks like, oh shit, especially when you draw it really bad. I don't know if, do you guys, so this is not more shit to worry about. This is, if I understand it better, I can see how I can make it work better for myself. So you got a couple things. What's a good scale? Great. Does the scale work with what the slope wants from me? I can play with that too. So just to kind of hammer that further home, let's take something that's not quite as freaky. How do I graph this here? Sure. What do you know?
Slope.
Slope is, what else do we know?
0,
Y-intercept is
0,
0, 2. Okay, so I can plot 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 5, 6. All right, so here's 0, 2, so where I start, and from there I go what? 1, 2, 3, over 4. Why did I pick 4? God. I'm trying to make a point here, so I'm going to do more than you normally would, okay? 1, 2, 3, over 4, right?
Mm-hmm.
Couldn't I just I can keep going, couldn't I?
Yes.
1, 2, 3, over 4. There it is.
It'll still be in
Now help me out. So that was 3 down over 4, 3 down over 4. What's this? This is how much down?
6,
6 down over
8.
8, which reduces to that. So I can use, I could have just not even done that middle point if I didn't want to. I could just do down 6 over 8 if I felt insane. Which I do often, which is exactly what I was doing right here. Any multiple of this it's just bigger steps. It's sort of like taking 2 steps at a time instead of 1. Don't you get to the same place? As long as you don't trip over yourself, but just assuming everything's good, right? So instead of taking 1 step and then another step, I could have just jumped down a few steps, right? And then fallen, and somebody posted on YouTube. It gets a lot of views. I can't make money because somebody cussed in the background. Shit.
large.
That's why I can't monetize my videos. I wouldn't try to. I would suck. Why would you want to watch my videos? A 15-second ad you can't skip. Screw you, Mr. Waller. No, I'm not going to do that. Is that better? Is that all right? So there are a couple ideas there that are a little more advanced, but again, it's all the same idea. And it has to deal with how do you make a problem easier for you to work with. You have a lot of choices you can make. What scale do you want? How do you want to handle the slope? Right? Which normally you wouldn't think. Here, this is a really bad example of wanting to do this, but I wanted to show you 2 steps do together make this one bigger step. And that's why this thing was valid. I'm just making 5 steps instead of 1. And it's easier for me to handle with my scale. That's it. Okay, Meg, is that all right?
Mm-hmm.
Or you're like, let's just say yes, so he'll stop talking about it. Okay. All right, anything else from Homer stuff? All right, I just want to do a quick, we sort of have been doing a review, which is nice. Let me think of, a couple other things, and then I got this handout stuff that's actually in the blue book, but I sort of reformatted it a bit. So, can you graph that for me, that line? So it's a line that goes to that point and has that slope. Graph it for me. know how to do this. There's nothing special truly about the y-intercept if I'm just graphing something. All I need is a place to start and a direction to go. Oh my God. All right, bam, bam. Let me see. So where do I start? -3, 5. And from there I go where? Down 4. 1, 2, 3, 4. Over 7. 1, 2, 3, 4, 5, 6, 7. I think I did right. Did I do right? I think so, yes. How do I check what I've done so far before I draw the line? What should be true about, what point is this?
4-1.
It's 4-1. What's got to be true about the point if I've done this correctly? It's got to do what? Well, shit. I didn't have an equation, did I?
Yeah, you put it in the equation.
If I had an equation, I could plug it. Sorry. Trying to make a point that's not the right time for it. Oh well. Too bad, Jeff. All right, now. Shit. Look at that. Just back-to-back shit. All right, let's see. Scheiße. Now, for my crappy drawing, it looks like the y-intercept might be something close to 3, right? Okay, so here's the last thing we did, I think, last time was, what's the other equation? We have this guy, but why is this guy not generally acceptable? Because what's B?
The y-intercept.
The y chunk, the y piece of the y-intercept, right? And do I have the y-intercept? No, I just have a point. I've got one point that I try to make every day. I mean, I got one point here. What's the other equation that I can use that's more general, that works for any point? I'll start it off. Y minus,
Y2 minus y1.
no,
Wait, no, what was the other thing?
y minus y1.
Equals x minus x1.
Do you see how if I divided those down, isn't it basically the slope equation? What happened to the little 2's on here is the understanding that it doesn't matter. If somebody has a point, what other point do I need to pick to get the slope? Any other point. The slope is going to be the same between any 2 points. That's because the line doesn't turn. So the slope stays the same. So if somebody gives me this point on this line, what other point do I have to choose? Any freaking other point. If I pick that one, I can figure out the slope. Pick that one, I can figure out your. Pick that one, I can figure out your. So that's why these don't have subscripts. They represent every point on the line, not a specific point. These have subscripts, so they represent the point that I know. So what can I put into that equation now? Y minus 5. The y piece equals m
-4 7.
x minus
-3.
-3. So is it cool if we make this?
Apparently.
Let me just put it in so you guys can see where it's coming from. So what's going to happen in there, of course? Let's keep going. It's going to get so, let me be really creepy. It's going to get so yummy here. Oh, that is really creepy, Jeff. Too damn bad. What do I do next to kind of keep clearing this up? I've got to distribute this. Oh, yeah. Let me do this part. There you go. I did half of it. Come on, this isn't that bad. What's -4 times 3? -12. Okay, whoop-de-doo. That was hard. All right. And then, where do you think I'm trying to go? What's the best form, the most concise form for a line is y equals mx plus b. So I'm just trying to get y by itself. So last thing I got to do is add 5. We put it over here like this. How do I add these? Stay with everybody cool with every step I'm taking so far? So the first step was plug in what I know, and then every step after that is clean up. Distribute, get your y by itself.
You get 23 over 7 or no?
Yeah, you know, like LCD, right? 35 minus 12,
Yeah.
right? 35 minus 12?
23.
23. You need a plus in there, Jeff. Help me out, guys. What is 21 divided by 7?
3.
3. What is 23 divided by 7? It should be a little more than 3, but I want my crappy scale. So the y-intercept doesn't always have to be pretty. I had 2 pretty points, and in the middle I knew it wasn't a nice number in the middle, and now I can see, oh yeah, it's a little bit more than 3, the y piece of the y-intercept, right? So shortagized my gross end.
What number is the one beside 4 on the point?
Oh, it's my excited one. Right,
Is that
4, 1,
Oh, okay.
right?
Where did you get that?
How did I get here?
Slope.
Yeah, slope. Slope tells me to go, how did I started here,
Yeah.
why? Because I knew it.
Yeah.
Then I went down 4 over 7.
Okay.
Now watch this. Now this is not that amazing. If I plug a 4 in here, what's negative 4 times 4?
16.
Negative 16 plus 23. Negative 16 plus 23. 7.
7.
7 divided by 7.
1.
1. So when I plugged a 4 in, I got a 1 out.
You went.
Okay. You guys are focusing too much on the fractions. The first step was easy. If they give me this, I just plug it in the right place. The other steps could be gross depending on what they look like, the numbers I plugged in. Decimals, fractions, they're just going to be a little gross, but oh well. Just power through. All right. One last idea, and then I want to give this to you so you can try some of this out on your own. What's true about parallel lines?
I have the shrine slope.
They're same slope. And of course, if you wouldn't answer like that, what's another way to answer that question? What's true about parallel lines? They don't cross. They don't intersect. And the only way two lines, if I have a line sitting here, the only way I can draw a line that won't intersect this is it's got to have the same slope. If the slope is a little bit different, it's going to eventually cross. So it only makes sense that